4.3 lemma. Let G be a region which is not the whole plane and such that every non-vanishing analytic function on G has an analytic square root. If A belongs to G, then there is an analytic function f on G such that first condition f of A is equal to 0 and f dash of A greater than 0. Second condition f is 1 1. Third condition f of G is equal to D is equal to set Z mod Z less than 1. Proof it. Define script f by letting script f is equal to set f belongs to h of G. F is 1 1, f of A is equal to 0. F dash of A greater than 0, f of G containing D. Since f of G containing D, supremum of f of Z, Z belongs to G less than or is equal to 1. For f in script f by Mondel's theorem, script f is normal. If it is non-empty, so the first fact to be proved. The script f not is equal to empty, it will shows that script f negative is equal to script f union set to 0. Once those facts are known, the proof can be completed. Indeed, suppose script f not is equal to empty and script f negative is equal to script f union set to 0. Hold and consider the function script f tends to f dash of A of h of G tends to C. This is a continuous function using theorem 2.1, and since script f is compact, there is an f in script f with f of A greater than or is equal to G dash of A for all G in script f, because uh, script f not is equal to empty. Script f dash is equal to script f negative is equal to script f union set to 0. This implies that f belongs to script f. It remains to show that f of G is equal to D. Suppose omega belongs to D such that omega not is equal to f of G, then the function f of Z minus omega divided by 1 minus omega dash into f of Z is analytic in G and never vanishes. By hypothesis, there is an analytic function h from G to C such that h of Z all square is equal to f of Z minus W divided by 1 minus omega dash into f of z. Since the Mobius transformation pi is equal to script s minus w divided by 1 minus omega conjugate into script s maps d onto d h of g is containing d, define g from g to c by g of z is equal to modulus of h dash of a divided by h dash of a into h of z minus h of a divided by 1 minus h of a conjugate into h of z. Then g of g containing d, g of a is equal to 0 and g is 1 1. Also g dash of a is equal to modulus of h dash of a in divided by h dash of a into h dash of a into 1 minus h of a whole square divided by 1 minus h of a whole square is equal to h dash of a divided by 1 minus h of a whole square square bracket whole square. But h of a modulus of h of a whole square is equal to modulus of minus omega is equal to modulus of omega, and differentiating h of z all square is equal to f of z minus omega divided by 1 minus omega dash into f of z gives. Since എന്തുകൊണ്ടാണ് f of a is equal to 0 ആണ്, ഇതെന്തായിട്ട് മാറും 2h of a into h dash of a is equal to f dash of a into 1 minus omega whole square. G dash of A is equal to F dash of A common ആയിട്ട് എടുത്താൽ 1 minus omega whole square ബ്രാക്കറ്റിൻ്റെ ഉള്ളിലുണ്ടാവും divided by 2 root omega into 1 minus 1 into 1 by 1 minus omega which is greater than f dash of a. This gives that G is in script f and contradicts the choice of f. Thus it must be that f of G is equal to D. Now to establish script f not is equal to empty and script s negative is equal to script f union set to 0. Since G naught is equal to Z, let B belongs to G and let G be a function analytic on G such that G of Z all square is equal to Z minus B. If Z1 and Z2 are points in G and G of Z is equal to plus or minus G of Z, then it is follows that Z1 is equal to Z2 in a particular G is 1 1. By the open mapping theorem, there is a number R greater than 0 such that G of Z containing B of G of A R. So, if there is a point Z in G such that G of Z belongs to B of minus G of A R, then R greater than 0, G of Z plus, then R greater than modulus of G of Z plus G of A is equal to minus G of Z minus G of A. According to G of G containing B of G of A R, there is a W in G with G of W is equal to minus G of Z. But the remarks preceding G of Z containing B of G of A R shows that W is equal to Z, which gives G of Z is equal to 0. Then Z minus B is equal to G of Z all square is equal to 0. B is in G, a contradiction. Hence, G of Z intersection set to script S from uh, modulus of script S plus G of A less than R is equal to empty. Let U be a disk. Set script S from script S modulus of script S plus G of A less than R is equal to B of minus G of A R. There is a Mobius transformation T such that T of C alpha minus U negative is equal to D. Let G1 is equal to T intersection G. Then G1 is analytic and G1 of G containing D. If alpha is equal to G1 of, if infinity is equal to G1 of, if alpha is equal to G1 of A, then G2 of Z is equal to psi alpha composition G1 of Z. So we still have that G2 of Z containing D and G2 is analytic, but we also have that G2 of A is equal to 0. Now it is simple matter to find a complex number C mod C is equal to 1 such that G3 of Z is equal to G2 of Z has a positive derivative at Z is equal to A and is therefore script as this is established script f not is equal to empty. Suppose script fn set to fn is a sequence in script f and fn tends to f in h of g. Clearly f of a is equal to 0, and since fn of a tends to f dash of a, it follows that f dash of a greater than or equal to 0. Let Z be an arbitrary element of G and put epsilon n is equal to Fn of Z1. Let Z2 belongs to G, Z2 not is equal to Z1, and let K be a closed disk centered at Z2 such that Z1 not belongs to K. Then Fn of Z tends to script Sn never vanishes on K. Since Fn is 1 1, but Fn of Z tends to script Sn tends to f of Z tends to epsilon uniformly on K. So Hurwitz's theorem gives that f of z minus script s never vanishes on K or f of z congruent to script s. So f of z congruent to script s on k, then f is the constant function script s throughout G. Since f of a is equal to 0, we have that f of z congruent to 0. Otherwise, we get that f of z2 not is equal to f of z1. For z2 not is equal to z1, that is f is 1 1. But if f is 1 1, then f dash can never vanish. So f dash of a greater than or equal to 0 implies that f dash of a greater than 0, and f is script f. That proves f script f negative is equal to f union set 0, and the proof of the lemma is complete. Then 4.10 corollary. ഈ corollary പറയുന്നത് among the simply connected regions there are only two equivalence classes, one containing of C along and the other containing all the proper simply connected regions. 4.10 corollary ആണത്. ഇതിവിടെ കംപ്ലീറ്റ് ആയി. ഇപ്പോൾ 4.3 ലെമ്മയും 4.10 കൊറോളറിയാണ് നമ്മൾ ഡിസ്കസ് ചെയ്തത്.